Hey, welcome back, you crazy cats. Today we're going to talk about how to solve combo circuits or combinations of circuits. And what that really means is that in this circuit we have both parallel concepts and series concepts. So what we've got here then is a combination circuit. This first one is hooked up in series because there's no the current can't split before it gets to this circuit. Then here we have a chance for the current to split. So here these two are hooked up in parallel. So this is the combination circuit. It's a good one for us to start off with. So what I've done here is I've drawn our chart over here. I mean, the chart is freedom. All right, it's going to allow you to be able to answer questions so much easier. But you've got to be able to fill in the chart. What I'm going to do with this then is I'm going to fill in the given information. I'm going to use our steps from earlier. So 9 volts, R1 is 2 ohms, we have R3 and R4. Let's just change these two. Let's make it simpler here. We're just going to make that R2 and R3. R2 is 6 ohms, and R3 then is 3 ohms. Now, excuse me, battling a little bit of a cold here. The second step is to find RT. Well, this is going to be something that several of you fight me on, but it's going to drastically help you. What we want to do is redraw this how it would look as if it was in series. And what we mean by this is these two right here are in parallel. So the first thing I can do is take these two and replace them with one resistor that is in series with the other one. To do that, I've got to find out what is the resistance total of these two. And that's going to be simply taking the inverse of 6 inverse, 3 inverse, and then, what is the answer to that? Alright, when we took the inverse of these two and add them, I got 1/2. Take the inverse of 1/2, and we get a total resistance of 2. So that means I could replace these two resistors that are currently in parallel with a resistor that is in series with the first one of 2 ohms, and I would get the same type of circuit. So I'm going to redraw this here then. And I don't get too complicated when I redraw them. That's a 2 and that's a 2, as long as you can tell they're 2s. Well, now that I've got this being represented by a series circuit, what is 2 plus 2? Well, the total resistance then would be 4 ohms. So what we did here again is we took this parallel, we found out what's the resistance total of these two, and then I redrew it as if we're changing it as if we were changing it to a complete series circuit or just a series circuit. And 2 plus 2 gives me 4 ohms. Well, now let's find IT. We know the total voltage, we know the total resistance. V equals I times R, 9 equals I times 4. I is going to be equal to 2.25 amps. So let's put that up here. Fourth step, use concepts. So here's where we're at right now. Use the concepts that we know. Well, here's what I know. I like it when series circuits or when combo circuits start off with one in series, because I know that series circuits all get the same current. So right now, if there's 2.25 amps flowing through here, and it's not had a chance to split, that means there still has to be, or that resistor 1 is going to get 2.25 amps as well. Because, I mean, let's face it, there's nowhere else it could have gone. Then I'm going to use Ohm's law. We're not going to be able to solve for all components at once. Some of you might have wanted to put I2 and I3 as 2.25 amps, but I can't, because right now, right here, the current splits. So some of that 2.25 is going to go down, and some of that 2.25 is still going to go to the right. So what I'm going to do here then is I know the voltage. 2.25 times 2 would be 4.5 volts. So that means there was 9 volts. Right here, there's only 4.5 volts left. Well, what concept do I know about parallel circuits? I know that parallel circuits get the same voltage, so that I know that both resistor 2 and resistor 3 are both going to get 4.5 volts. So I can put down 4.5 volts right here. Now that I know the voltages for these two, the current becomes really easy. It's 4.5 divided by 6. Divide both sides by 6, and it becomes 4.5 equals I times 3. So divide both sides by 3. And for those two currents, we get 0.75 amps and 1.5 amps. What that means then is that resistor 3, that line had 1.5 amps going through it. The other line, the resistor 2, had 0.75 amps going through it. So where we had 2.25 amps, it splits, and that's why we couldn't say that both of these were getting 2.25 amps. Part of that 2.25, which was 0.75, and the other part, which was 1.5 amps, went down this line. Alright, so here we have a new one. It's a very similar setup, but our first step is still to put in the givens. I'm going to pause it and put in the givens. Now that I've put in the givens, our first step is to find the total resistance. So what I need to do then is to redraw these two that are in parallel and find out what would their equivalent resistance be if I were to replace them with one resistor and put it in series with the first resistor. So that would be 6 inverse plus 30 inverse is going to be equal to that total or equivalent resistance. So when I did that, I got 0.2 is what the inverse of the total resistance was equal to. So RT was 5 amps. Well, now that I know that what RT is, IT becomes very easy. And that's just going to be 6 equals 5 times I. IT in this case turns out to be 1.2 amps. Well, again, my first resistor, okay, so let's redraw this, sorry. Because I just did a bunch of things that are not right. That's what happens when you're a little bit sick and you're trying to get ahead. What I forgot is, I forgot to redraw it. Alright, I was guilty as my own students. We have 6 volts, and it has a 20 ohm resistor, and we just said that we can replace these with a 5 ohm resistor. So what's our total resistance? 25 ohms. And it would be 6 equals I times 25, or I would be equal to 0.24 amps. 0.24 amps. So what that tells me then is that I have 0.24 amps traveling here. So resistor 1 is in series. What do I know about series circuits? I know that they're going to get all the same current. So resistor 1 is going to get 0.24 amps. I can't say that about resistors 2 and 3 because they are in parallel. What I can tell you right now is that I times R is going to give me the voltage. So voltage across resistor 1 is going to be 4.8 volts. So there was 6 volts. We just lost 4.8, so we're now down to 1.2 volts. That tells me then that the voltage across resistor 2 and 3 are both 1.2 volts because they are in parallel. Well, I think at this point you guys can find the individual currents for these. So hopefully at this point now you guys can start to answer some questions here. I want you to state 2 rules for voltage and current in a series circuit. State 2 rules for voltage and current in a parallel circuit. And then I have a question for you. If you remove a single bulb from an inexpensive string of Christmas tree lights, all the lights in the entire string will go out or go off. Are the bulbs connected in series or parallel? Explain. Hey, I'll catch you crazy cats on the flip side.